Okay, so this is a sample of an estimate of a fuel rail, and you can see here in design profit, there's a few parts in here, but we're going to go to the fuel rail, which is right here, and see a small picture of the fuel rail there, and a larger picture here, and you can see it's a plastic part, fairly complicated, a lot of eye locks, a lot of action in the tool to make this part. The part used to be steel. Found out we could make it out of plastic through design profit studies and save the customer quite a bit of money. So open up the fuel rail right here, and you can see these. We give it a part number here, 1111, and called the fuel rail. And if we go into the custom fields here, we can start to see some of the parameters of the part. If we look at the dimensions, you can see that we have 12.2 inches in length, and we have 2.5 inches in width, and 3.1 inches in height, with a wall thickness of 0.0860 inches. And actually we have a built-in calculator here too, which will give you a rough idea of the weight of the part by selecting the basic shape of the part here, and then selecting the amount that is removed from the projected area of the part, and then any additional material for additional ribs and bosses on the part. But that will give you a rough estimate of the weight of the part. So here now I've selected the costing of the material, and you can see that I put in 0.2799 pounds, and that is the net weight of the part. And this particular mold I've chosen is a hot runner manifold. So the part, there's no runner system or off-all involved. It's a clean part when it comes out of the tool. So you see the 2.799 pounds. And what the system has went in and done from the material I selected on the first screen up here, 40% short glass polyether, and that is $2.25 per pound. And what it does then, it calculates the roll-up into dollars. So the total material cost in the part at this point is $0.63 US dollars, 63 cents. So our next step now is to take a look at the cost button here, and it'll generate a cost for the part for us. So I want to continue, and what it's doing is building the part right now. And you can see here I can select a technical data package if I want to add that to the cost. I can select receiving of the materials into the plant if I want, but I want to focus today just on the process. And you can see here that it's an injection molding process, and you can select changeover, and what I've selected here is SMED. If you're not familiar with that, that's single minute exchange of dies, and that's anytime you have a system where you can change your dies or molds in under 10 minutes. So that's what I've selected in this case. I'll go ahead and close that. And the next thing is the type of runner system, and you can see I've selected a hot runner, and that is indicating that there will not be any runner off-all. If I'd have selected cold runner, I would have been able to select the percentage weight in the cold runner. And you can see here for inserts, I don't have any inserts in this part, so no inserts is selected. And the next thing for me to select is the type of injection molding. And you can see I have a lot of different types in here, including gas foaming, liquid foaming, powder foaming. But this is just standard injection molding. I'm not adding any foam to the part. And down here we have projected area percent. Oh, and if we go over here to the side, you can see I've selected 50%. So this is the way you see the part laying on the tool. How much of the area is the actual part covering on the tool? That's what that's referring to. We'll close that. Now colorant. I'm not selecting colorant. In this case, I have black material, pre-colored in black. I buy it that way. I'm not adding any liquid or powder or pellets to the machine to color the part. Material is already colored coming into the machine. And unloading parts, I can unload them manually, or I can use a robot, or I can just drop the part out of the press, and that's what I selected to do here. Just dropping it down, and you can see I've selected using a conveyor, so the parts are going to convey out of the press to the side. And then similar on inspection, I can select the type of inspection I want to do on the part. So if I say OK at this point, I'll get a cost for the part. Say OK again. Okay, now since we selected cost, you can see that the system has generated a process to make this part, injection molding. You can see the machine center here, number of mold cavities, number of die lock features. We selected a hot runner manifold. It's automatically selected a 55-ton press based on the part size and the number of cavities we selected. It's added a chiller to the mold for this material, and it's also added the PCU to control the manifold. And up here you can see the changeover of the tool and the time it takes to change it. And you can see we've got 5 minutes, 4 minutes, and 1 minute. So just on 10 minutes for this system to change. And then you got the cycle time of the injection molding press with shot properties. And here's your injection molding time in seconds, plus the part dropping out of the tool in seconds. So now we can see the executive summary, which gives us the total cost of the part of 98 cents. You can see the cycle time, and we've assigned one operator to watch this press, take care of it, and we could reduce that to a half an operator possibly. We can do that after we ran this part for a while. And then the labor cost, 17 cents, the machine cost of 5 cents, the material cost of 63 cents, and Q burden, we haven't selected anything there yet, but we can easily go in and select quality burdens. So the SG&A is 8 cents, so the total accounted cost for me to manufacture this part is 94 cents, and I've got 4 cents of profit, and those are all individually settable in the model, and then a total of 98 cents for the part. So that'll be it for today's example of the fuel rail.